Good day, this is Mr. Weiss, and this is Physics for 9E and 9F, and it's May 29th. So, I'm opening up my books. We'll get some folks online and take roll right now. So, good morning to folks, and as soon as you get on, go ahead and let me know you're there with a hello, and I can get you some participation points for tuning in. It's a Friday, and I've got Philip is with me. That's a good thing. Good morning, Philip. There he is. Who else? I got Nicholas. And I've got Tony. Hello, Tony. And I got a fourth person. Let's see if they say hello. And we'll get some others on joining us, I'm sure, in just a moment. See if you can see that here today. Get the whiteboard in action. Lucy is there. Very good. Yeah, and we're going to do some more with finishing up radiation today. 9E has had this, but 9F needs to have gamma, and we'll finish up with beta before that. Then we'll do a couple reactions, everybody, just to sort of see how this works with the numbers before we go on to half-life. That's what we'll start in the second half of this live stream. So that's our plan. Beta, gamma, and radiation or decay, and then some half-life. Good, I got some others joining me, and it is Ali and Julian L. Very good. I've got Benedict. And I've got some others now joining, so go ahead and say hello if you have not yet. And folks, if you know someone who may not know the live stream is happening, go ahead and text them so they can maybe get a heads up if they forgot and then join us. That would be great. You go ahead and text anybody in 9E or 9F to remind them. And so far, I've got 1, 2, 3, 4, 5, 6, 7 of you. And I'm hoping for a couple more. There they are, a whole bunch. I got Noah Delphs. I've got Malin Falk. I've got Felina Sedan. Super. And I've got some more coming on. Wow, a whole bunch. I've got Leah. I've got Lena and Tom. I've got Julian K. And Magdalena's here. Good. Thanks, Leah, for the heads up. I've got Ben. I've got Santiago and Muriel. I've got Lucy. Oh, they just keep on coming. I got Lee. I got Sarah. I'll give like one more minute and then we'll go ahead and start up. Thanks for holding on, everybody, especially the early folks here. Just want to make sure I get as many folks involved as I can. There's a couple more. Shilpa and Larissa. Nice group this morning. That's super. And just a few seconds here, and we'll see if I get any more. And we'll call that good for now. Okay, what I want to start up is before we do physics today, I have 3 questions for you as a group. Thanks, Marilyn. I think I might have asked 9E some of this already. I can't really remember. Kira's here, good. Here's the first question. In general, how are you guys doing with this whole online learning thing at home? How are you doing in general with this online learning thing? You can type in me some comments, please. Christian, welcome. Okay, some fine, some good, some all right. Hard to concentrate, I believe that. Especially if you might have siblings in the house, might be pretty hard to concentrate sometimes. Harder than normal school, I agree with that. There's Priya. Thanks, Priya. Too many big projects. Well, that could be annoying. Good as it can be. Vincent says hello. Hello, Vincent. Thanks for joining us. Teachers don't answer questions. That's too bad. I hope I'm not included in that. If you ever have any questions, you can ask me either through email or on the Google Classroom. You can just text me something there too. Okay, my next question's a little more involved. I'm getting an answer from Leah as well. Ah, yes. Ooh, lots of siblings makes it difficult. Sometimes we procrastinate too, just because don't have a structure as much at home. hmm And Natalie's here. Welcome, Natalie. Okay, my next question is, um, I don't want this to be like a complaining session, but do you have some, uh, I should back up. I'm on the ED committee. That's the Educational Directorate Committee, which helps to steer the school. We'll meet again in mid-June, and I want to ask you for some feedback for teachers. So what's going right? What could be better? Do you have any suggestions or feedback for teachers that you want to type in? Thank you, Deacon, for joining us. Gotcha. Anybody else say hello, but we're doing really well today, a nice number of folks. So yeah, give me some feedback, not just for me, but for all your teachers. And I want to take your ideas to the Educational Directorate Committee for suggestions for the fall, quite frankly, if we're going to do more online instruction in the fall, which is a possibility. Okay, having assignments due on Friday, that would be nice. My another group I asked suggested that we have more assignments given by teachers on Monday. So in other words, they sort of know what they need to do for the week, and I'm taking that with me as an idea. And Priya agrees there. Let's see what Shilpa has to say. So you're getting some teachers that do assignments without explanations and without any Zoom or YouTube type meetings. That doesn't seem so effective for me. I know I don't do Zoom with you, but I like the YouTube things. And if I can read quick enough, whoa, here they come quickly, then I can get some good feedback from you on any classroom day, but particularly today. Okay, do Monday, Wednesday, Friday. Okay. Okay, and Ali says we got some work without notes or explanations. And that may be from me too. I think I'm guilty of that, but we're going to provide some notes today, by the way, explanations for the work I assigned you already. Yeah, more on that later. Yeah, ask questions and talk. Some teachers do Zoom meetings, some don't. I hope I'm still with you. Looks like it cut out for Lena for just a minute. Yeah, I'm hoping with bigger projects, Tom, if we start all using Google Classroom, you'll get heads up when your assignments are due. That might make it better in the fall, because I've had a criticism that too many teachers are using different platforms. And Natalie has a friend in the US with all of her schedule on Zoom. I have read that you can have too much Zoom. 2 or 3 meetings a day is more than most people can handle. I know I find it exhausting just doing the live streams, but Zoom is supposed to be even more difficult mentally to have a lot of hours of it. So we want to maybe not have all of your schedule on Zoom. Good question, Sarah, about feedback, grading grades. They've not given me a good way to give feedback. And I know some teachers are doing this, but legally we're not supposed to give you your feedback for assignments on Google Classroom. So that's why I'm not doing it yet. I hope that can be figured out for the fall because I want to have some way to tell you how you're doing. What I'm going to do from now on is when I grade something, I'm going to give you a comment, a personal comment, not with your grade, but at least roughly how you did on it. Okay? So I hope that will be somewhat helpful. Yeah, Tony, that's why I picked YouTube because it can be watched for those that can't make it. Sometimes technical difficulties or appointments or too many siblings in one house, so it's pretty hard. And good suggestion, Ali, to get more teachers trained in on using Google Classroom. Do you get reminders, Priya, from Google Classroom when something's due, or just one reminder? How does that work for you? Hi, Riley's here as well. Good. Welcome, Riley. I see. In some, the teachers don't tell you anything. Well, that's disturbing. Yeah, it'd be nice to get you guys a progress report, Lena, in some way. And legal, I want to find out a way we can do that with the okay of the Berlin Senat. We don't get reminders on Google Classroom. Priya tells me. Okay, so I hope at least you see at the top something like assignments, and then they have like when it's due. You can also post it to a Google Calendar if you're into that sort of thing. So, okay, Leah says it does give notifications when she has a new assignment, and that's probably good, okay? If we have the app downloaded for our phones. Ah, okay, so that's it. Good thing for me to know. So the app on phones will give you a heads up when you have a new assignment. Good, okay. It tells you the night before if you have notifications. Thanks, Noah. Ryan is here. Ryan, thank you, but you're not in my class, so you don't need to be here. You can maybe go to your own class. But nice to hear your hello. Okay, there was one other thing I wanted to ask you. What was it? Oh yeah, just so I kind of know, how many other than me, how many of your other teachers are doing Zoom meetings or YouTube or something that's live? Roughly give me some numbers. How many of your other teachers are doing this? Barely any. One, two, three, two others. Only one other. Four. So it really varies. But it sounds like less than half your teachers are doing this. Some are assigning work without a due date or not assigned work. Ooh, that's a little disturbing. One other. And Amir is here. Thank you, Amir, for checking in. Somebody could, by the way, text these people to have them join us. I'm missing Maurice still, Micah and Emily, Alyssa, Malek, Jason. If you want to text any of those, 9F. 9E, if you want to text Noah, Devante, Aiden K, Cosima, Dominic, that'd be great. Maybe they can join us. Okay, my last question for you is, do you have any, and by the way, let me tell you again, I'm asking you all this because I want to take your information and internally take it and report back to the ED committee meeting I have in mid-June. That's a committee that helps kind of direct the school, okay? So I'm not asking just for the heck of it. All right, and thank you, Leah. Last question I have is, do you have any personal challenges that this has made for you in the whole Corona, being at home, trying to deal with classwork? What are your personal challenges with this, if you'd like to share? Okay. Alyssa's here. Thank you, Leah, and welcome, Alyssa. Any personal challenges you have that you'd like to share, some special difficulties that make this time hard? Then we really will get to some physics, I guarantee. And Cosima's here. Good. Welcome, Cosima. Ooh, only once a week class with lots of assignments. I hope you can speak with that person, or at least write them and ask them if they could ease up a bit. I probably give less assignments than other teachers, but then I'm trying to also teach you live, and I feel that that counts as well. That's why I'm not giving you that much. Malek is here. At least she can't type, but she's here. Thank you for the heads up, Lena. Hello, Malek. Appreciate that. Appreciate your help in that. Really hard not meeting your friends. Boy, that is so true. Yep, I feel the same. And it's hard to focus. There's a lot of distractions, especially in the internet and at home, isn't there? I find that true too. Yeah, so procrastinating, not seeing friends, these are difficult things. Hard to stay focused. Hmm. And Riley has a restriction. Riley, if it's not working, you can always, I think, try and look at them on YouTube afterwards. I'm sorry you're having technical difficulties for this. I'm not sure why they would be restricted. I feel like I'm not learning that much. Okay. Well, my goal, frankly, with you is to have you learn enough physics so you're ready for next year. We're doing pretty well. We're actually fairly close to what we need from nuclear physics. We got like 3 or 4 other big topics, which we'll be able to cover in the next few weeks. So I think I'm going to transition and, transition back to physics. And I'm going to put my attendance books aside here and get back to what we were doing. Get my markers and get ready. Okay, so we're going to review a little bit, and then we're going to look at the Aufgabe, the assignment that I assigned to you. And I'm still reading a couple comments. Physics is helpful, but other classes don't teach us new information. Oh, and that's not good, Natalie. I know it's sometimes we have to do last minute, but it's not really easy for you to do a Zoom meeting in just a few hours. That's pretty silly. Yeah, agreed, Ali. Now, as a teacher, I'll tell you from our standpoint, it's been hard because we don't always know when we're going to be in school till the week before. So it's hard sometimes to plan live streams, at least for me. If they're not doing that, I guess they don't have that problem. Okay, you ready? Let's go ahead and start. So I want to talk about some reactions of decays, and we did this last time. So let's review a little bit. I tell you what, let's do it with, we said we had what? Alpha, beta, and gamma, right? I know alpha we finished up with everybody. Beta, I think I've only done with 9E. 9F, can you tell me if we did an example yet of a reaction with beta decay? So 9F, can you look and see in the last live stream, did we do a reaction yet with beta decay? Yes, yes, or no, no? No. Okay, then we're going to start right there. Okay, beta is pretty weird, and I think we talked about it, everybody. 9E can help me out here, okay? So beta is what happens, 9E. I've got this thing is going to be a neutron, and what happens in the nucleus? So maybe Leah even has it too, because she wrote what happens in the nucleus. So what happens in the nucleus? If this is beta decay, something kind of weird. This is a neutron, and it's in the nucleus. What's this thing going to do? Electron radiation. Good. So the electron flies off. Tom has that. Boom. Away it goes. That's my beta particle, by the way. It's an electron. What happens to the neutron? What does it become? Let's see what somebody says. Becomes a proton. Marilyn has it, as do several others. Exactly. So beta means the electron, a neutron, which is made of an electron and proton. The electron flies off. That's the beta particle. And this becomes another extra proton. So let's do a reaction. You ready? Here we go. How about number, I don't know. Oh, man, I need my periodic table. If you got a periodic table, pull it out, because we're going to need it big time today. I got to grab one from my 8th grade. Hold on. Ta-da! Look at that. I got everything here. Everything in a basement you could possibly want. Okay. Okay, let's say we've got Y, yttrium. That's a fun one to say, huh? So let's say we got Y, and it's right there. It's number 39. And I'll say this is a beta decay example. And again, 9E can help me out here because I know they've done some of this. So we got yttrium. And down at the bottom left, you might remember that's where we put the number of So the bottom left's the number of And I'm going to put the number there, and you can tell me what that is. So it's got 39 what? It's got 39 what if it's yttrium. I'm going to tip that so you can see it. This is just what we're starting with. This is my reactant. Got 39 what? And the top number I'm going to put 40, 42. No, that's not right. Sorry. I misread it. Let's put 92. Okay, it's a number of protons. Thank you, Shilpa, Tom, and Kira. So 39 is a number of protons called the atomic number. I put up here 92. Can everybody see that if I tilt it forward? So the top left is 92. That's the number of protons plus neutrons. I'm going to move along a little bit, so I can't ask every single time somebody to answer, but I'll ask sometimes. If it's beta, let's see what happens. Okay, so there's my reactant. My product is an electron. You guys told me that. Electron can also be written like this. A big B, like a German et said, for beta particle. That's the same thing. So sometimes I'll write or beta. You could have beta here instead of an electron. And what happens, okay? Hey, it's not 39 anymore. Somebody help me out. What's my bottom number now during this process? It's not got 39 anymore. What's happening to the bottom number? 9E knows and 9F, let's see if you can kind of figure it out. What happens to the number of protons at the bottom? Good, 9E has it. Let's see if any 9Fs have it as well. Can figure it out. Let's see, Lee, you're 9E as well. And yes, I got a 9Fer. Leia's figured out too. So it moves up. I got a neutron became a proton, so now I got 40. So now it's a new element. We'll figure that out in a second. What about the top number? The top number is the number of protons plus neutrons. 92 protons plus neutrons is the one I gave you to start with. There's no way you could come up with that. And Lee knows what happens. And let's see if 9F can figure it out. Okay. So if a proton becomes a neutron, and this is the number of neutrons plus protons, then the top number, and I'll just take it from 9E at this point, stays the same. So if it was 92, it's 92 again. But it's no longer yttrium, yippee. What element is it? Somebody look it up on your periodic table. It becomes a new element. Isn't that strange? So it's no longer yttrium, it's what? Look it up. Find a periodic table back of your planner or the paper one I gave you. And I'll answer your question in just a sec. It becomes zirconium, so ZR. So Nicholas has it there. Why? Because ZR has got 40 protons. Okay, so here we go. Let's say in my nucleus, I got 3 protons, right? Well, this one's a neutron, okay? But if it shoots off an electron, I got another proton. So now I got 4 in here. So that's what I mean, Leia. I gained a proton, so it's no longer the same element. It now is an element with 1 extra proton. So I went from 39 to 40 in this particular case. Huge. And Amir and Magdalena had that, as well as Riley. Good. Thanks everybody for participating. And Tony, that's super. Are we okay with that? Okay. And again, the electron is the beta particle. We'll see what that does to you, maybe at a later time. Let's go on to gamma. By the way, beta abbreviation is also a big B. You might see that sometimes in physics. And for gamma, it looks like a fish swimming down. I think we had that already. And for gamma, again, I know 9E had this, so I'll ask you guys in 9E, what happens in the nucleus during gamma radiation? And I'm going to tip this a little so you can see a little better. What happens during the nucleus 9E during gamma radiation? Gamma. What happens during gamma radiation in the nucleus? Ooh, Sarah's quick on the draw, and so are a couple others. Good. The protons and neutrons shift position. Yeah, it's like getting comfortable in a chair. They just change a little bit to a little lower energy position. So protons and neutrons shift to a new lower energy position. And what they give off is just what? Larissa has it. They just give off some light. Okay, so I write here, giving off light. And the light is called gamma rays. Gamma rays. So gamma is pretty easy. That doesn't mean it's not important, but it's pretty easy to understand. Let's do a gamma example. Where can I fit it where you can see it the easiest? Let's do a gamma example right here, okay? Okay, I'm going to take something that does some gamma, and that would be like plutonium. So I'm going to do Pu. It doesn't smell, but it is pretty radioactive. Pu has 94 protons, and I'm going to pick a plutonium isotope. Remember that word, isotope? So various numbers of neutrons. I'm going to pick one that is, I don't know, 244 is unstable. Sure, what the heck, we'll just pick that. Maybe we'll pick 245 just for grins. So what happens is I get light, and I'll just put the symbol on it, which means gamma rays. Okay, that's this guy. So gamma rays is that symbol. Plus, what happens to my element and what happens to the numbers? 9F especially. What happens to my plutonium in terms of its numbers? It's giving off only light, therefore good. 9E has it. 9F, I want to see if any of you are responding as well. I don't want you to feel behind or rushed. And Kira has it too. The numbers stay the same. So I end up with still plutonium 245 94. Maybe you say, huh? Why? Huh? Again, think of like you're in a chair, you're not comfortable, you scooch around a little bit. Well, the neutrons or protons scooch around a little bit sometimes too and get in a position where maybe they're lower energy and they give off a little light as that happens. Then things go to lower energy. Same reason that things fall, give off some energy in terms of potential going to kinetic energy, right? Well, instead of that, it's a little bit of energy given off as they change position. And it's given off as a ray. Okay, now you know what happens with alpha, beta, and gamma. And now, ta-da-da-da, let's look at the worksheet, okay? Oh, some of you have it, 9E maybe, and 9F only has a picture of it, or I sent you a Google Doc or something. I got a question though, let's see. Tom asked, what kind of energy state is the nucleus shifting to though? As in, what type of energy is being changed? Tom, it may be a type we really haven't studied yet. And it's interesting because there's what's called a binding energy. You might have wondered, Tom, and everybody, how it is in the nucleus all these protons stay together. Why don't they fly apart, right? They're all positive. Remember we learned that? Positive things would repel. But the neutrons help them keep together like a kind of glue. And they call that a binding energy. So I think, Tom, that binding energy is changing a bit when they shift position and go to a lower energy situation and give off some light. I don't know the details of that. I haven't studied that enough in my long life. But that's as much as I can do. Okay, so you're going to have this sheet, everybody. It's on the assignment that I gave you. Let's look it over and make sure you can do it. Okay, number 1, 2, 3, state whether it's alpha, beta, or gamma. I bet you'll be able to do that. I bet you'll be able to do that. Good, Tom. By the way, electrons are sometimes written like this. You ready? I know I can write an electron as E minus, or here's the fancy way in nuclear reactions to write electron. It's E, and instead of a proton, they put a -1 down here. It's kind of weird. And they put a 0 up here. So don't get all, both of those are an electron, okay? Don't get all weirded out. So don't panic. And instead of an alpha particle, I'll write that down here. I can put an alpha particle with this little fish symbol, or I can put a helium nucleus like this. Helium 2, 4. And sometimes they have a little +2 up there. Do they do that in this worksheet? No, they don't. Okay, so I won't bother. So either of those would be an alpha particle, okay? Alpha particle. It's just a way of learning how to write things in physics. So I think you'll be able to do 1, 2, and 3. So that says just tell what's alpha, alpha, beta, gamma. 4 through 9 has fill in the blanks. Ooh, let's see how bad it is. Fill in the blanks with the correct particle or the decayed nucleus that will balance the reaction. Hey, some are tricky. Look at that. Some you go forward, see that? And 1, you got to go backwards. So if I got to go backwards, sometimes you got to add numbers or figure out if it's beta, what I got to do with the numbers. So just think logically. You guys are pretty logical this year. So look at them and figure out what I got to do with the numbers on the top and bottom to figure out how to fill in that blank. And then 10 through 13 says, write a balanced decay reaction for each of them undergoing the decay in the manner stated. The first one's supposed to do a beta, the second one an alpha, alpha, beta. I think you'll be able to do that. The last two say give the product isotope when something undergoes alpha, and then the next one, something undergoes beta. I think you'll be able to do this homework now. I think you will be able to do this. If you have questions on any of them, write me either an email or a comment in the Google Classroom stream, okay? And I will answer those. But I think you should be able to do it now. So you can make a copy of it, okay, in Google Docs, fill it all in, and then upload it in Google Classroom. I think it's due in like a week or something. So does that help now? Does that get you started? I think you'll be able to do that now. Especially 9F. I hope that's enough for you to get going on it. Share 9F with those that are not here, because they may need some extra help. Okay, that puts everybody about the same spot. We okay? All right, I'm going to change whiteboards. Look at this poor one broke. Look at that. I've used it so much. It keeps falling off the wall. So I got to find myself some duct tape, just like we use out in Montana. Okay. Oh, I got my other one. Should I just use that? Hold on. So we're going to shift gears, put up the other whiteboard, and hope it stays. Come on, buddy. Stay there. And we're going to talk about half-life. Yes, it's fallen several times, unfortunately. Okay, so what the heck is a half-life? (9E), can you help me out? What the heck is half-life? It doesn't mean I'm 15 and if I die at 30, this is half my life. No, luckily not. Okay, Tom is quick on the stick there. The time it takes for an element to decay away half of it, yep, from half its mass. Okay, right. So it's a time. It's an amount of time. Time for half a radioactive isotope. Remember, most atoms are not radioactive. So we got to have a radioactive isotope. If it's a stable one, it won't do anything. Reminder. Okay? Good. Several of you knew that. Good, including Ali and Shilpa and Lee. Good. Okay, so time for half a radioactive isotope to decay. We're going to see today why it's pretty useful, and that'll be new to 9E and 9F, okay? They vary a lot from seconds or a fraction of a second to billions of years. So sometimes things decay really slowly. Okay, maybe in 10,000 years, one of these things will do a beta, all right? Or one of these things will do an alpha or something, okay? And maybe really quick. Sometimes it happens so fast, like a nanosecond, which I can't even do it that fast with my hands, right? It's too quick. So the half-lives really vary. Okay. Where do we use this idea, this weird idea? We use it to figure out how old things are. Have you ever heard in the newspaper, oh, they found this Roman temple and they found out it was this old? Or they found this piece of pottery and they dated it. They found out how old the pottery was. Well, this is the method that they use, okay? It's called radioactive dating. Radioactive dating, okay? This does not mean on a Friday night that you go dancing and give somebody some uranium, all right? It has nothing to do with actual dating. Instead, it has to do with using how much of this stuff has decayed to figure out how old an item is. And we're going to do that together in just a just a little bit. Yeah, Ali is giving us a special type of radioactive dating called radiocarbon. We're going to use that in just a sec, Ali. So we're headed that way. Yes, indeed. We may not even finish today, but we'll get started. Okay, so radioactive dating. So methods, there's more than one, of determining the age of a sample by seeing how much radioactive isotope remains. And it really is methods. There's some methods that use potassium and argon, and that's to tell really old rocks, like we're talking about billions of year old rocks. That's how they know the Earth is really, really old, like 4.6 billion years old. And others are used like rubidium strontium. Those two are used as a pair. One decays into the other to figure out how old things are, like rocks where dinosaurs are found, right? So 1 to 300 million years old. And then the one Ali mentioned is one that gives relatively young dates of things that contain carbon, right? Like bones or maybe some pottery or something, okay? And we're going to learn how to use that probably next time. Let me see what people are saying here. Make sure I answered any questions. Yeah. Do they use a Geiger counter for this? No, not really. They can't use a Geiger counter for this, Santiago, because Geiger counters don't tell the type of radiation. So it could be from a radioactive carbon, it could be from radioactive uranium or plutonium or calcium or who knows what. So they'd have to use another instrument to measure this amount of stuff. And what they use is an instrument called a mass spectrometer. So they measure literally how many atoms of this mass with more neutrons compared to how many atoms of this mass with less neutrons. So it's a machine that sorts out things by weight of the atom, if you can imagine that, even though they're super, super tiny. And then we get a ratio like a comparison, right, from math class. Here, let's tip that so you can see it. And the ratio allows you to see, oh, how much of my radioactive stuff is left. If there's not much left, it's pretty old. If there's a lot of radioactive stuff left, it could be a fairly young sample, like not much time has gone by. Okay, we're going to start there next time when I see you all, okay? Pardon me, and do some number examples together. As well as probably get into fission as well. But let's just see your comments before I close off here. Exactly, it's got to be a living organism to use radiocarbon dating, right, Santiago? Yeah, the carbon was created a long time ago, but it keeps decaying. And when a creature dies, Tom, it turns out that that process of breathing stops, not surprisingly. And so we stop interacting with the carbon in the environment. And it's like starting a stopwatch as soon as you stop breathing. And that's true of all creatures. But we'll talk about that more, Tom, the next time. Good. Thanks, everybody, for weighing in, for participating well. We'll see you at our next live stream or maybe live someday. Hope so. Hope you're all well. Try and stay focused and, yeah, have a good long weekend. Bye.